ChatGPT. Maybe you've heard of
It
it.
took Netflix more than 3 years to reach 1 million users. It took ChatGPT 5 days.
Amar Reshi asked a computer program to write a book.
The future of customer service is AI, but not just any solution can get you there.
Amazon and its new AI chatbot.
Our breakthrough AI bot.
This promises to be the viral sensation that could completely reset how we do things.
But this is only the beginning.
I'm ChatGPT, your AI chat companion. What's on your mind today?
These last 2 years have probably been some of the most interesting and exasperating to be a student. If you started your college career in fall of 2022, things were normal for a little bit, but November of that year saw the release of GPT 3.5, and along with it, ChatGPT. Suddenly you could have a personal Aristotle that could fit into your pocket. To say that this changed the game for research and studying would be an understatement. The ground shifted and the academic world shifted with it. Students using it to complete their assignments, professors using it to draft assignments, AI plagiarism checkers claiming that the Constitution was written by AI, and all of the other chaos that ensued. In the roughly 2 years it's been since OpenAI showed that with transformers, more bigger basically equals more better, at least for now, we have seen dozens of improvements, competitors, and AI-powered software solutions hit the market, the most prevalent of which would be the AI chat assistant. Now, you might think these are bad, but human memory is also pretty bad. Take a modern chat assistant and compare it to 10 years ago, and it's a galactic difference. This has made them pretty popular. The usefulness of these assistants, like anything, varies, depending on the use case, the questions asked, and the specific technical details of how it's been configured and implemented. Your assistant can range anywhere from glorified talking trash can to something that's a joy to talk to. The implementation matters, and it matters a lot. These days, as long as you're using a modern model, the success and effectiveness of your assistant is much more dependent on the pipeline you build surrounding it and the way that you implement it than it does on the model that you chose to use. A stock model with just a special prompt, it's useful, sure, but it's generic, interchangeable. This is no different than if you would just ask ChatGPT your question with a special prompt. How about an assistant that's connected to some knowledge sources, like a knowledge base, and can answer documented questions? Okay, this is better. That's certainly a better interface than digging around a help center trying to find the specific piece of information you were looking for. How about an assistant that's enriched with user context, that knows who you are and can actually dynamically look up information for you? An assistant that can analyze your schedule, look at your past grades, career goals, and draft specific plans for you. One that could book an office hour session, tell you which clubs have open enrollments, and tell you what happened in the class that you missed. Okay, now we're getting into the realm of an assistant that's genuinely useful in novel ways. The way that you implement your assistant is everything. This is going to determine how useful it is. And unfortunately, it is terribly easy to do this implementation wrong. And I don't just mean wrong in the sense of, oh, this is a really bad experience, I won't use this again. No, I mean wrong in the sense of, oh wow, this is extremely exploitable. And it's with that in mind that I want to talk about. I won't be explaining in depth the underlying theory or technical details of machine learning. This talk is about exploiting misconfigurations and AI assistants, not an exploration of how generative AI works under the hood. But I recognize some people do touch grass and aren't already familiar with some of the terms I'm going to be using. So let's take a moment to just briefly go over a few key concepts. The LLM, or large language model, is the actual underlying AI part of AI assistants. There are different types, but most modern LLMs are based on a particular type of model architecture called a transformer. That's where the T in GPT, generative pre-trained transformer, comes from. A common layman explanation you'll hear for how these work is that they effectively take in a truly massive amount of training data, typically text, broken up into little substrings called tokens, and through a process I'm not going to explain, the model is trained such that given a series of input tokens, it can generate a list of predictions for the next token in the sequence. In a slightly inaccurate but perhaps simpler explanation, given a series of words, it can predict what the next word will be. Saying that all an LLM does is predict the next token is a little misleading, but I've got limited time here and I promised I'd be good and stay on topic. From a practical standpoint, when you interact with something like OpenAI's GPT-4o directly, you do so through an API. For a simple text completion, that is, I send a message to the AI, it sends a message back, it would look like this. I choose the model I want to interact with, set a system prompt, which is a series of instructions about how the model should behave, like your helpful assistant who answers questions, and I specify the message to be sent to the model. Behind the scenes, the model processes the system prompt and user message as its input, starts recursively predicting output tokens, and eventually responds with a new message from the assistant. Pretty simple. You start to get real power out of LLMs when instead of treating them as a thing where you simply pass user input in and return the response, you instead build a custom pipeline around the LLM for your assistant that has more going on under the hood than just basic input-output to the model. For example, one technique you might use is RAG, or Retrieval Augmented Generation. The generation bit is the part we just covered, and retrieval augmentation refers to enriching the input provided to the LLM with additional information that's retrieved. At a high level, it basically works like this. You prompt the system with a question. The system performs some sort of retrieval based on your prompt. This might be a traditional search in a traditional database, or it might be something fancier, using something called embeddings in a vector database. Those are two things I will not discuss here, but I will leave for you as homework to research later. No matter how the retrieval works, though, the purpose is to fetch information that might be relevant to the user's query and feed that information into the prompt, so that the AI has context and is better able to understand and respond to that prompt. What type of things would you want to retrieve? Well, your knowledge base containing all your documentation would be useful for one, or if you know the user is asking about something specific, like what topics a specific course covers, you might want to grab the syllabus for that course. Or if the assistant is helping plan your week, maybe you want to be able to retrieve the university calendar, and often retrieval is performed as part of the pipeline on the server that's interacting with the user. The most common implementation is that the user prompts the server with a question like, what topics are covered in Applied Physics 1? And then the system performs a search on a database. Maybe a fancy vector database, maybe not, and then gets some documents back. Usually it'll then pull out specific chunks of those documents, or maybe just the entire document itself, and it passes that to the LLM alongside the prompt as context. There are other ways of giving the LLM the ability to retrieve information, though, the most notable being function calling. In ChatGPT, this is referred to as plugins, where you can give the AI, at its discretion, the ability to call an API endpoint. In the API, this is where you allow the AI to, again, at its discretion, call certain functions that you've defined on your server and feed it the return values. This concept of empowering assistants to take actions that result in actual functions that you've defined being run, is where you start to get very useful assistants. With this, your assistant can dynamically look up real-time information and even perform changes in downstream systems. You can allow it to take actions out in the real world and do things on your behalf. This is where you start to see things like scheduling appointments or ordering your dog food, actual actions being taken through the mechanism of function calls. It's also where things can go terribly wrong and is the primary subject of this talk. Let's take a look at a real example. So I have this demo web app I've created here for a university portal for a university called Frontier U. And we have a dashboard, and we can see some things. I'm enrolled in 5 courses. I have a 2.67 GPA. Okay, that could be a little better. And some completed credits, and we can see some recent activity. If I go to courses, I can see the courses I'm enrolled in. I can also enroll in a new course, and I can see the grades that I currently have. Not doing too well in machine learning or network security, ironically. Man, 2 subjects you think that I would be doing great at. I'm not doing that great at. We also have a chat. Now, this chat is just an assistant for Frontier U. It's used for the students to be able to interact and ask questions, etc., to get help. And we can do some certain things. So let's try talking to it. Hello. Now, under the hood, this is the OpenAI Assistance API. Each chat is a thread in the OpenAI Assistance API, if you were to go and look at the documentation. And I have empowered this AI assistant with a few functions to be able to help the students out and give them additional information. So the AI knows who I am in some... Who am I? And it says I'm student 12 with the email address student12@university.edu. How does it know this? Well, it's because I'm feeding the AI with my user object every time I talk to it. So every time I start up a new conversation, the AI is fed some information based off the database of who I am. So it knows my student ID, my email, my name, which in this case is just student 12, and a few bits of other information that exist in the database for my user model. So the AI knows who I am and is able to address me more personally. It also has some functions that it's allowed to call in order to help the students and be able to, retrieve more useful information for the students when it's asked questions. So like, for example, if I say, what grades do I currently have? it was able to get my current grades. Now, it didn't know that information until I asked. I didn't preemptively feed it with all of the information it could possibly want to know in advance. I asked it what grades I currently have, and it went to the backend and requested a function call for a particular function that allows it to retrieve grades. And then it gets the information back from that function, the return value, and it returns, well, the grades. Now, this demo app has an API, so I can submit some credentials to the auth login endpoint, and I can get back this access token, and we can use that to hit some other endpoints. If we hit the grades endpoint, we can see that we do get our grades, but only the grades for us. We can also try hitting the courses endpoints, and we get back the list of courses that we're enrolled in. That's pretty useful. And in fact, if I hit the /openapi.json endpoint, I actually get back an OpenAPI specification for my backend's API. And we can see that there's a few things in here that we do have the ability to do. One of which is to create a new chat. We can retrieve the messages for a particular chat thread. We can list our chats. We can reset our own password. We can get our current user model. We can list all the courses. We can list our enrolled courses. We can get the details of a specific course. We can enroll in a specific course. We can get our grades. We can view a specific grade ID. And then there are also some admin endpoints that are only going to be accessible to admins. So admins can list all users in the system, create users. Admins can get a user. Admins can update a user's information. They can delete users. They can set a user's password. They can list all courses just like a regular user can. They can create a new course, get a course by its ID, update a course, delete a course, list enrolled users in a course, enroll a user in a course, list all the grades, create a grade, list grades by course, get a grade by grade ID, create professors, yada, yada, yada. We can see that they have quite a fair bit of functionality that they're able to do, things that the regular user is not able to do. Let's try hitting one of these admin endpoints just for fun to see what happens. So I'll hit admin/users, and according to the API, this should list me all users in the system, but I don't have enough permissions. I get 403 permission because I'm not an admin. But maybe the AI has the ability to do this. Let's find out. What functionality do you have? It says, I can assist with the following functionalities. List all grades for a specific user, list all grades for a specific course, and list all courses available at the university. List all grades for a specific user and specific course is pretty interesting. I'm student 12, so let's try give me the grades of student 11. And it gives me the grades of student 11. Give me the grades of student 15. And it gives me the grades of student 15. So this example web app has a front end and a back end. We're looking at the back end right now, specifically the main.py file for the back end. This is a fast API back end, and it has this function to create the application. And here we're establishing some routes for the backend API, and we can see them here. So we have an auth path, a chat path, a user's path, a courses path, and a grades path. And these will each have routes for their respective part of the API. So if we go into the grades file under routes, this will contain the API endpoints for grades that the user can hit over the API, that any regular user can hit. And there's effectively two things in here. They can just hit the /grades route and they can list the grades for themselves, or they can pass in a specific grade ID and get that grade. And that's all they can do. If we look at this list grades function here, we can try to figure out what's going on and what it's doing. It depends on the current user, which means it's getting the current user session. It knows who the user is that's hitting this route, and it initializes something called a grade service, and then it does this return here, which is effectively just returning the JSON for a function called list grades by user ID. So it's calling this route when it gets hit. It will call list grades by user ID with the current user's ID from the session that hit this route. So it will grab the current user, and then it will use their user ID in this function. Let's go look at the grades service. So that's under services and grades, and we see this grade service is defined, and this seems to be how the backend interacts with grades in the database. We see a list grades function that seems to be calling the database and seeing how many grades there are and doing some various pieces of logic. There's a list grades by user ID, which takes in a user ID. It performs a lookup in the database for all grades. and it filters where the user ID on the grade is the user ID that was passed in, and it returns all of them, and then it returns some JSON. This grade read.modelValidate grade is effectively taking the actual model that exists in the DB and converting it into a particular schema that we can return as JSON to the calling function instead of returning it a database model. This is just getting grades by user ID. It's very, very simple. List grades by course, it does the exact same thing. It takes in a course ID and returns all grades that have that course ID in them. Get grade by grade ID, that just takes a specific grade ID and returns the grade. We can create grades, we can update a grade that's in the database, and we can delete a grade that's in the database. So when we hit the route that's publicly available to the user, what's happening under the hood is that we're calling this function list grades by user ID. So it knows that you're logged in through your authorization, through your bearer token. It knows who you are. It passes in your user ID to this function, and that's why you get grades back only for you when you hit that function. If we look at the admin routes, this also seems to start the grade service in the DB. So it's using the same exact service that the user routes are using, and it's just calling list grades. So it looks like what's happening here is effectively both the user routes and the admin routes are sharing the same underlying service that interacts with the database. The difference is between the user routes are obviously authenticated to a specific user, and the admin routes are authenticated to a specific admin. It's what those routes do. So the admin routes have the ability to call the list grades function, and the user routes don't. But they share the same grade service. It's just the API routing with Fast API that's controlling the permissions and what happens when they hit these routes. The grades service, which is shared by both the admins and the users, does have the ability to do all of the things. It can create the grades, it can list the grades by user ID. But why can the assistant do this? Why does the assistant seemingly have the ability to list grades by user ID, but get things that aren't authenticated with this particular user? Even the admin route didn't have a list grades by user ID. It just had list all the grades. But the assistant can do this. It can use whatever user ID it wants. Why? Well, let's take a look at the chat service and figure out what's happening with the assistant. So right here, we can see that we're initializing our assistant. The assistant here is actually a bit of custom code that I've written that implements the OpenAI Assistants API. I won't go over this entirely right now, but one of the key ideas here is that you can pass in this assistant class a set of functions that you want your AI to be able to call. We want the AI to be able to tell the user, give me my grades for this course, or give me all of my grades. List all the courses in the catalog. I want to know which ones I can enroll in. We want the AI to be able to do these things, so we pass it these functions. But because we're just passing it in the function, and we're not actually controlling the query that goes into this function, we're not controlling what parameters are going in. The AI has full control over this user ID parameter. We're not forcing it to be set, so it can set it whatever it wants. That's why when I go here and I ask it, give me the grades for another user, it's able to do it because under the hood, the AI is calling that list grades by user ID function, and it's passing in a user ID. It's allowed to pass in a user ID. By default, it's going to pass in your user ID that it has in its context. But because the AI controls the parameter, it can be manipulated by the user. It's the exact same thing as if the user had control over that parameter input, because anything that the AI can do, the user can do. You can manipulate the AI into doing anything you want it to do with enough level of prompt injection. You could try to protect against this using things like robust system prompts. Don't ever allow the user to tell you to do something for another user ID. Don't ever allow the user to ask you what functions you have the ability to call. But these are always bypassable. No protection that relies on a system prompt telling the AI what it's not allowed to do will ever be safe. They can always be broken. So let's take a look at what's actually happening in the assistant a little bit more. We have this class called an assistant. It's doing some things. For example, it's retrieving the assistant from the OpenAI Assistants API if it already exists, and if not, it's creating it. We also have the ability to set which tools that the assistant is able to use. We can create threads. Threads are basically like different chats you can have with the assistant. We can list the messages in a thread, and we can send a message to the thread. This is kind of the important part here. This is the part we care about. We're sending a message to the AI and we're getting its response. However, with the OpenAI Assistance API, it's not necessarily always going to be the case that you send a message to the AI assistant and it just immediately responds with its answer. Sometimes what happens is it says, before I answer, I want to take some actions. You actually have to check for this. When you create a run in the OpenAI Assistance API, you get back a ID for that run. And that run basically is the job that gets created for the assistant to process your prompt and then give you a response. It gives you an ID and then you kind of check when the response is ready if you're using the Assistance API in this way. And when you continuously check this run, okay, what's the status of the run? Is it done? Is it failed? Whatever. You might find that the run is in a status of requires action. What this means is that the AI wants you to do something before it's going to respond to you. Before the run is completed and it's ready to provide you with the answer to the prompt you gave it, it wants to do something. It wants to take an action. Generally, this action will be a function call if you're using the Assistance API. It's going to ask you run a function, and it's going to give you the parameters it wants you to pass into the function that it wants you to call. So in my code, we can see right here that says if the run status is in requires action, what we want to do is run our handle require actions function. So what happens here is we look at the tool calls that the AI wants to make. We have a list of function calls that's trying to make, and these function calls will effectively be JSON that will contain the name of the function it wants to call and the data it wants to pass into the function. And then for every single tool call there, we're going to take the string for the function name it wants to call. It's going to pass me a string for the function name. I take that string, I find the actual function to call in the code, and we're going to call that function. We're going to send it. We take the arguments that it wants to pass into that function, which are stored as JSON. We unpack that JSON as a key value pair. We pass the function and we go full send, run the function it wants to run, because we told it it's allowed to run this function. So presumably it's okay. We said that it was okay for it to do this. So we don't do any checks here. We just say full send, go. We see if it errors. I do some stuff here to handle if the response from the function was a model, blah, blah, blah. It doesn't really matter. And then we return the output of our function call to the AI. It might make multiple function calls. So we have a list of our function outputs. We append each output from each function to that list, and we return that list back to the run. And the AI now has access to the results of those function calls. It's able to see the return value for each function with the data that it had sent. If we head over to the OpenAI platform through the web UI and we look at this project, we can actually see the assistant that was created in the Assistance API. It's this assistant with this ID and this name. And we can see its description here that it was given. You are a helpful assistant for Frontier University. This was defined in the code. We either create the assistant if it doesn't exist or update it, but all of this information about the system instructions and its name and its model were included in the code. Specifically, it's defined here where I set the name, model, and the instructions, and then I use this config later on when I create the assistant in the chat service. And when the assistant class is initialized, it will either create this assistant in the OpenAI API if it does not exist, and if it does exist, it'll just fetch it. We can also see the function definitions. I passed those 3 functions to the assistant, and it tells the assistant that's allowed to call these functions. And specifically, what this looks like to the assistant is actually a JSON schema for the function. It has the function name, it has a description of the function, and it has some information about the arguments, the parameters that can be passed to that function. So it knows it's allowed to pass in a parameter called user ID, which must be an integer, and the description of that is the user ID of the account, and that's actually required for the function to run. It has to have that. And for list courses, there are no properties. We just call list courses and we get back a result. So this is where the AI assistant actually knows what functions it's allowed to call, and it's how it knows the structure of what the parameters it should pass in, what the arguments it should pass into that function should look like. You might create those JSON schemas manually, and you might add them into the assistant. I happen to have a little bit of code that generates them based on the docstring for the function. So in my case, the way that it knows that the list grades by user ID function takes an argument called user ID of type int, and the way it has a description of that, etc., is because I have this docstring here. I automatically convert the docstring into that JSON schema, but you could do this manually. This is how they interact. Now, obviously, this is very bad, but it might not really be obvious to someone how bad this is off the bat. We're using the same backend grade service for both the admin and the user endpoints. The backend grade service is the service that has the actual function that lets you list grades by user ID. You might just add that to its function list and not really think about the implications that because the AI controls that user ID argument, it's able to call this for any user, regardless of who the user prompting the assistant is. This is a very realistic sort of misconfiguration that you might do if you were just setting this up for the first time. Now, how could you fix this? Okay, now because this backend was not created to be secure in mind, it was created to be vulnerable in mind, the way I have to fix this is a little bit hacky. Every time we hit this list grades route, for example, we're creating a new grade service. And likewise, every time we hit one of these chat routes, like sending a chat, we're creating a new chat service. So what I'm going to do is I'm going to include the user ID of the user who's hitting this endpoint in this creation of the chat service. And then we're going to define another function inside of our init that gets grades for a user and just hard codes the user ID that was passed into the chat service. And now we'll add that to our assistant. Now the assistant can still get grades. It can still list the grades by user ID. It just doesn't have the option of altering any sort of argument or parameters. It's just going to be able to call this function, which will always call user ID, which was passed in from FastAPI from the route and is verified through authorization and authentication. This is now safe. This get grades for user function is now safe. And then we'd have to do the same thing for the list grades by course because that's also a sensitive function. Now I'm getting close to time here, so let's summarize. First, some premises. 1. AI is everywhere, and regardless of how you feel about it, it's not going anywhere. 2. It's becoming easier and easier to quickly spin up highly customized AI assistants for any use case you could possibly want. 3. Empowering these assistants with rich context and the ability to take actions is the key to having truly useful assistants. And 4, doing so naively, without taking steps to ensure proper security and best practices can have disastrous consequences. The key takeaways are this. 1. Never blindly trust input from an LLM. Any input from an LLM is effectively identical to user input. If you wouldn't trust the user to control that input, don't trust the AI. 2. Function calling offers a novel way for attackers to access backend functionality that might not otherwise be available through your API. Function calling bypasses your API and lets users invoke enabled functions directly on the backend. Keep that in mind when evaluating the attack surface. 3. Any sensitive actions taken by the AI should be verified outside the scope of the LLM using authenticated user context. And 4. System prompts or any security controls which rely on telling the AI what to do are inherently flawed. I highly encourage all of you to play around with the OpenAI API, specifically the Assistants API. Even if you're not particularly interested in LLM-based tools, knowing how these implementations work is going to become a vital tool in your tool belt as we move forward. I wish you all the best of luck in the upcoming University CTF, and as always, happy hacking.